Okay, so in this lecture we will start with elementary particle physics. So our topic is elementary particles. Okay, so what is meant by elementary particle? A particle is said to be elementary if it has no substructure. That is, it is not made up of any other kind of particles. So, a elementary particle is the fundamental particle and it has no substructure. So, an elementary particle has no substructure. It is a fundamental particle. Fundamental particle of nature. So, now according to standard model of particle physics, standard model of particle physics, we have at present sixty-one elementary particles. Now, what are these 61 elementary particles? Now, these elementary particles are grouped into several groups. So, these are the groups in which these elementary particles are divided. These are number one, the leptons, in which the electron, muon, tau lepton and neutrino, these particles are belong to these leptons. Okay. Then we have antileptons. Then we have quarks. Then we have antiquarks. Then we have gauge bosons. And last is the recently discovered scalar boson, that is the Higgs particle. Higgs particle belongs to this scalar boson. Okay, so we will start with these leptons, then antileptons, and we will discuss what are the elementary particles. Now, leptons are the spin half particles. Leptons we have 6 kind of leptons. First bit is the electron. Electron, it is denoted as small e. It is a negatively charged particle with spin half. Okay, and its mass is 0.511 mega electron volt divided by c square, where c is the speed of light in free space. Okay, then we have muon. It is denoted as small mu. Then we have another lepton, that is called tau lepton, or this is called tau, this is tau or tauon. This is also called tauon or tau lepton. See, muon is a lepton which is much heavier than electron, and it is negatively charged particle, and its spin is 1/2. Tau lepton is also a lepton, and its spin is half. Electric charge is minus, that is negative charge, and it is much heavier than electron and muon. Okay, then comes the neutrinos, that is electron neutrino. These are very light particles, electron neutrino. This is denoted as nu with suffix e. Then 5, muon neutrino. This is denoted as nu with suffix mu. And corresponding to tau lepton, we have another neutrino, that is called tau neutrino. So we have tau neutrino, that is the sixth lepton, that is tau neutrino, and it is denoted as nu with suffix tau. Now these neutrinos are very light particles, that is their mass is less than 5 electron volt divided by c square. So they are very light particles. Now we have these 6 leptons in nature, and corresponding to each lepton we have one antilepton. So electron, the antiparticle of electron is positron. It is a particle, it is a fundamental particle whose electric charge is just opposite to that of the electron, and mass is same as that of the electron, and spin is also 1/2. So antileptons that is first come the positron. It is denoted by E bar, that is the antiparticle of electron, that is positron. Okay, similarly we have antimuon, and it is denoted by mu bar. Okay, then 3 we have anti-tau, lepton, anti-tau, so it is denoted by tau bar. Okay, then we have antineutrinos, that is electron antineutrino, electron antineutrino, and it is denoted as nu e with a bar sign. So the antiparticles are denoted by putting a bar over their corresponding particles. So electron antineutrino, then we have muon antineutrino, and last is that tau antineutrino. So fifth, we have muon antineutrino, nu with suffix mu, and we have to put a bar over this symbol. Okay, now, and last is tau antineutrino. And it is denoted by nu with suffix tau and a bar over it. So we have 6 antileptons, 6 leptons. So we have discussed 12 particles, that is 6 leptons and 6 antileptons. So we have got 12 elementary particles. Okay, now we will go to quarks. Now quarks are the fundamental particles. Many of you know that proton, neutron, these are made up of quarks. Now we have 6 kind of quarks, or poetically it is called flavor. So we have 6 flavors of quarks. So quarks are of 6 types. Now first comes the up quark. Up quark, it is denoted by small u. Now up quark, then comes down quark, denoted by small d. Then we have charm quark, C. Fourth, we have strange quark, then we have top quark, and sixth is the bottom quark. So these are the 6 flavors of quarks. Now what happens? See, each quark come in 3 colors. Color means they have color charge. Like electric charge, we already know that electric charge we already know. Now in case of quarks, we have some other kind of charge which are called color charge. So each quark comes in 3 colors. So it has 3 colors. Down quark also has 3 colors. It has 3 colors. Strange quark, it has also 3 colors. top quark, it also comes in three colors, that is three color charges, and bottom quark, three colors. So each quark come in three colors, so we have 6 into 3, that is 18 type of quarks. 18 type of quarks we have in nature. Okay. Now corresponding to each quark we have anti-quark. So corresponding to each quark we have anti-quark. Now, since we have 18 quarks, so we will have 18 anti-quarks. So, we have 18 anti-quarks. So 18 plus 18, that is 18 quarks, 18 anti-quarks. So we get 36 kind of quarks and anti-quarks. And leptons we have got 12, that is 6 leptons and 6 anti-leptons. So there we got 12 particles, and here we are getting 18 plus 18, 36. So 12 plus 36, that is we have got 48 particles. Now comes gauge bosons. Now what are these gauge bosons? These gauge bosons are the particles which carry the forces. That is, we have the forces in nature. We know that there are 4 kind of fundamental forces in nature. First one is the gravitational force, second one is the electromagnetic force, third is the strong force, and fourth is the weak force. Now gravitational force, we will not talk about gravitational force. So in particle physics we have mainly 3 kind of forces, that is electromagnetic force, strong force, and weak force. Now these gauge bosons, these are the particles which carry this force, mediate this electromagnetic interaction, strong interaction, and weak interaction. So gauge bosons first comes the photon. All of you know what is a photon. It is a massless particle which has always speed c in free space, and its rest mass is 0, and it mediates electromagnetic interaction. So it is a massless particle. Massless particle which mediates electromagnetic interaction. Okay. Then after photon comes 8 kind of gluons. So 8 colored gluons means gluons are the particles which have color charges. 8 colored gluons. So these are massless particles which mediate strong color interaction. Okay, so we have 8 kind of colored gluons. So we have got 9 particles, 1 photon and 8 colored gluons. Okay, then we have W plus, then W minus, these are the electric charges, and Z0 bosons. Now these 3 particles, they have mass, means they are massive particles. So these are massive particles which mediate weak interaction. Weak interaction. Okay, so we have got, see, 1 photon, 8 gluons, so 9, and 3 W plus boson, W minus boson, and Z0 boson. So these are the massive particles which mediate weak interaction. So we have got 12 particles. So earlier we got 48 particles, now 12 particles. So 48 plus 12, that is 60 particles we have discussed. Now the last one is the scalar boson, which is the famous particle recently discovered in Large Hadron Collider in the year 2012, and it is called the Higgs particle. So scalar boson, it is a scalar boson, it is the Higgs particle or Higgs boson. Higgs particle. Now it is a massive particle. It is a massive particle